Good morning, Year 9. Today we are up to Lesson 9. So Lesson 9 is to use the trigonometric ratios to find unknown angles. So your success criteria is to say, I can use a calculator to find an angle correct to the nearest degree given the trigonometric ratio. I can use a calculator to find an angle to a specified level of accuracy given the ratio. And I can use trigonometric ratios to find unknown angles. Okay, let's have a look what we are doing. Lesson 9, finding unknown angles. And we're going to need our calculator, so I'll put that up there. So our learning intention is to use a trigonometric ratio to find unknown angles. Now we've already done this, functions on your calculator labelled sine minus 1 or sin minus 1, cos minus 1, and tan minus 1 can be used to find unknown angles. Make sure your calculator is in degrees mode. Reset your calculator if you're unsure. Now I've already done a bit of a video on that and how to do different calculators. If you've got, most of you have this sharp one, there's a little button here that you can push reset will reset your calculator, and the degrees you need is up here. You need DEG written here. If you've got RAD, or my old calculator when I was in school used to have GRA on it as well, you need it in that degrees mode. And the easiest way with this calculator is simply to push the reset. It'll take you back to that mode. So if we're looking at our calculator here, you can see we've got sine, cos and tan. You can see that sine minus 1 is in brown or orange above it. Cos minus 1 is here, tan minus 1 is here. To get to those, you push the second function button first, and then you push this button. That gives you the function which is in brown or orange. So the sine minus 1, cos minus 1, or inverse sine, inverse cos, as it's also called, and the inverse tan functions are written in yellow and orange on the calculator body and above the sine, cos and tan buttons. To use them, first push the second F or second button, then push the sine, cos or tan buttons. I'm just going to pause now, and we'll just bring up the abacus one as well. So the abacus one's got second on it, it's yellow, and they're in yellow. This one over here is all orange. You use the second function. Okay, so let's have a look and see if we're given already the ratio A over C. If we want to find the angle, we just need to put the numbers in. So this here hasn't got any real examples, but if sine theta is equal to A on C, where A is a number, press second function sine, put your bracket in, A over C, close your bracket. Now, depending on the calculator, you can either put that in as a fraction like that, which a lot of people find easier, or you can use A divided by C, and we'll have a look at both of those. If cos theta is B on C, push second function cos B on C. These letters obviously relate to here. And then if tan theta is A on B, so tan theta is the opposite over the adjacent, press second function tan A over B. Right, so let's have a look at that example. First example, find the angle with ratio sine theta equals 3 on 5 to A, the nearest degree. So that was one of our first success criteria. So let's have a look, and then afterwards we're going to find it to one decimal place. So what we're going to do here, sine theta equals 3 on 5. Looking at our calculator, which is here, we're going to have theta is equal to, so it's the inverse, theta is equal to sine minus 1, 3 on 5 is how we write that out. And so we've got second function here, brings up the sine minus 1, you can see it. Now in this calculator I don't need to put brackets in, but what I might do is, and it doesn't come up with a bracket, but good practice, I'm going to put in 3, and to begin with I'm going to put that in as a fraction. I'm going to go 3 over 5. Then I'm going to close my bracket and I'm going to go equals. That gives me 38.869. If I'm giving that to the nearest degree, I'm just looking at this here, this place here. So I look at the one after, it's an 8. I'm going to round up 37 degrees. So 37 degrees, if I'm giving it to 1 decimal place, which is what this asks me for here, 1 decimal place, 36.9. 1 decimal place, have a look here, the 6 I round up as well. My second example, find the value of theta to the nearest degree for this one. Now, in this one, it hasn't told me what I'm looking for. So I've got to go back and label my triangle. I can see here, I've got theta here. There's my angle. Now my right angle is here. I should have marked it on there. So I should have maybe put this in here. You're not going to lose any marks, obviously, if you don't, but that there indicates that it is a right angle. And then what I want to do is I want to mark my sides. So A is between the angle and the right angle. The hypotenuse is opposite or facing the right angle, and O is the other one. And have a look at what I've got, what information I've got. I've got a 6, which is next to my O, and I've got an 11, which is next to my H. So I have O and H. The ratio with O and H in it is SO. So I've got sine theta equals O on H. Substituting in sine theta, the O is 6, the H is 11. So my theta is sine minus 1, 6 on 11. So if I look at my abacus one now, we'll see if we can get rid of that thing. Can I throw it down there since I pulled it up? Okay, so sine minus 1, second function, sine. So it's given sine minus, it's given me my first half a bracket on this on this one, 6. Once again, I'm going to do it as a fraction. And then with this one, if I'm doing that, I need to push this thing to get it up to the vinculum, to get it up in the middle. That's something that you have to do. So there's pluses and minuses with these calculators. These ones, as far as the screen goes, all looks a lot nicer, but quite a bit at a time. You have to do a little bit more work. So 33.0, I'm finding it to the nearest degree. So it is 33 degrees. My last example is a worded question that we've got here. And so it's asked me for, it's saying that a 15-meter ladder standing on level ground, which means it's horizontal under here, has its foot 8 meters from the base of the wall. Find the angle that the ladder makes with the ground. So I've got 8 meters here from the base of the wall. It's told me the ladder is 15 meters long. So I've got 2 bits of information there on finding that angle. Give your answer to the nearest degree. So again, looking at that, what I'm going to do is I'm just going to take it away from here. This would normally be given to us in a paper. I need to, as in a question, your book, whatever, we need to draw it, or I'm going to draw it out. So what I can see here is I label it. A is between the angle and the right angle, and I can see it's a bit of an ongoing theme. I forget to put in my little right angle square there, which would be better if I did. And then I have got H is facing the right angle, O is the other one. Now I can see here I've got 8 next to the A. I've also got 15 on the H. I've got A and H. The ratio that uses A and H is K. So cos theta equals A on H. Substitute in my numbers. My A is 8. My H is 15. So theta is cos minus 1, or the inverse cos of 8 on 15. Pulling up my calculator, I want, and I'll just clear that, I want second function cos. Give me cos minus 1. I'm going to put my bracket up there. 8 on 15. 8 over 15. Close my bracket. Equals 57.76. 57.7 to 1 to the nearest degree is 58 degrees. Okay, so what you've got here is you've got some questions here. You've got these ones here. I'll go through and colour in the ones I want you to do. The harder ones down here, you might say some with a picture associated with them. Okay, have a good day and send me an email if you have any questions.